Hey everyone, thanks for joining. We're going to wait a few minutes just to have a few more folks log in, and then we'll kick things off. We see a decent amount of folks are joining now, so probably just wait another minute, and then we'll get started. These are the moments I really wish we had a live countdown clock to build up the excitement. All right, perfect. Thanks everyone for joining. Happy Friday. This is a special edition of our weekly tech drop-in. We're joined today by the Oracle Solution Center to discuss how to simplify hybrid multi-cloud architectures. Just a few housekeeping items. Feel free to drop questions into the chat at any time, but just make sure you're aware we do have time at the end of the presentation for live discussion as well. We have a great team presenting today. To kick things off, my name is Chris Cabel. I'm the Senior Director of Global Cloud Solutions here at Megaport. I've been with Megaport for about 7.5 years, and I manage the relationship with Oracle globally. I'm joined by my colleague, Kevin Dresser. Kevin, do you want to say a few words?
Sure. Thanks, Chris. Yeah, I'm a solutions architect here at Megaport. I've been here for almost 4 years. I'm also on the alliances team, so I work pretty closely with all of our partners, such as Oracle here. So looking forward to the presentation. Thanks.
Kevin. Also joining us is Matthew, or as his friends call him, Sebastian of the Oracle Solution Center. Matt, please introduce yourself.
Yeah, thanks everyone. This is Sebastian, our Director for Partner Solutions and Partner System Integration at the Global Oracle Solution Center. We're part of a global organization called the Revenue Operations within Oracle. And between two stints, I've been with Oracle for about close to 2 decades now.
All right, perfect. And to get things started, Matt's going to talk a little bit more about the Oracle Solution Center.
Yeah, so first off, it's a great honor to be here presenting alongside Megaport. So just to introduce the Solution Center itself, as I mentioned, we're a global organization. We got some key goals in terms of how we reduce risk for our customers. We help customers by reducing their complexity and accelerate their innovation adoption. We get into all kinds of leading edge technologies, and we span the Oracle product stack in terms of its breadth. We're into almost every kind of deployments. And our whole goal is to enhance the customer experience and also lower your total cost of ownership. Now, we understand the importance of reducing risk for our customers. Our customers are faced with a lot of complex multi-platform, multi-product ecosystems these days, and they need to modernize at the speed of business to keep up within their innovation and budget and business demands. So we help solve for these kind of challenges by reducing the complexity and increasing their innovation adoption by modernization. A big emphasis is on moving to the cloud and different cloud variants, cloud platforms in terms of cloud adjacency, hybrid multi-cloud solutions, and also Gen AI enablement for businesses. So what is it that we bring to our customer in terms of capabilities and services? We give our customers, like I said, a choice of flexible deployments and a test before you invest kind of paradigm. So customers can solve for complex, heterogeneous, cross-platform interoperability and reduce their risks by using these deployments in our solution centers and developing blueprints and best practices before they actually roll it out into their own business. So we offer a variety of services like proof of concepts, architecture evaluations, especially with new hybrid and multi-cloud architectures, cloud adjacency, workload analysis, and sizing estimates. We help with solution validations and demos. We also have a focus on executive briefing, where we prove of values, TCOs, and scenario-based investment strategy modeling for executives who are visiting, so they can derive positive business outcomes. So next slide. And today, specifically with Megaport, a significant OP and Fast Connect partner for us, we've built easy to deploy multi-cloud solutions with split stack applications, connecting between OCI and other cloud providers. So I'll pass it on to Chris to highlight some of Megaport's value proposition for our multi-cloud solutions.
Perfect. Thank you, Matt. So as mentioned, Megaport is a top global Fast Connect partner with over 1,000 connections over our network today, supporting 355 plus Oracle customers. Our footprint with Oracle is constantly growing, with 31 global locations available today. And as Matt mentioned, our alignment with the OSC really just ensures that our users are maximizing their OCI workloads. To give you a little bit broader scope of Megaport today, we provide over 2,600 customers access to the top service providers across the globe, supporting 165 cities in 26 countries and growing. We've spent over a decade building a massive global network across over 930 data centers. What we've done is we've actually put gear and sites across the globe, physically interconnected those sites, and interconnected with the top service providers to really build a future-proof network platform. Over the top of that network, we've actually deployed a custom software layer that gives you complete control of the network using our web portal, or even more automated via code with our Terraform provider or API. By leveraging Megaport, customers have the ability to deploy scalable connectivity to the top service providers across the globe on demand. And with various options to access our platform, users can leverage their existing POPs and/or deploy virtual POPs, right, or points of presence. This provides high level of performance without the need for large capital expenditure. And even better, because all of our solutions are one-to-many, deploying resiliency for high availability is not cost prohibitive. So why is a vast network ecosystem important? Matt's going to dive in a little bit and walk through some of the key trends and challenges that he sees in the current landscape on a day-to-day basis.
Yep. So we talked about reducing risk and complexity and accelerating innovation adoption in the previous slides. So there's primarily about three paradigms that we're seeing in terms of what are trending at this point. Moving from legacy to modernized systems, there's need for private and public and private infrastructure, and there's a lot of emphasis placed on data residency. So there's quite a bit of data, about 40 to 50% of the world's data that's still on legacy systems, and that needs to be modernized with the newer cloud applications for rich feature function and enhanced insights. So interplay of IT systems from on-premise to the cloud is becoming more common. The second trend that we see is reduced latency requirements. So due to the cross-cloud applications and cross-platform applications residing on different stacks, we've got things like split stack architectures that demand really reduced latencies to meet application transaction SLAs, and especially to sustain core business applications in a split stack fashion. We'll look at what a split stack architecture is a little later down the line. And so the third paradigm we're seeing is data governance and security. So obviously, modernizing to the cloud and cross-platform multi-cloud ecosystems still need to keep in mind that there's regulatory frameworks, frameworks like SOX and HIPAA compliance, mandate the customer's data to be in a certain region, and the security now has to be holistic in a cross-cloud ecosystem. It's as though you're operating in a single tenant system, but with a security holistically across clouds. So that becomes a big challenge and is a trend that we closely watch and address. So let's look at cloud value beyond adoption. So we've gone beyond the traditional paradigms of just cloud enablement and adoption at this point. So on this graph from McKinsey on the right especially shows that the global 2000 revenues is likely to hit about 56 trillion by the year 2030. Of this, more than 3 trillion EBITDA is projected to come in as business enabled through the cloud alone. And from this 3 trillion, there's approximately about 60%, that's about 1.7 trillion, that will be driven by accelerated product development and hyperscalability. A lot of accelerated new development is coming in from the APAC and Americas due to acceleration in newer technologies like AI and machine learning. And there are several hundreds of thousands of new born in the cloud applications that are spurging this demand. So here we talk about flexible architectures that meet some of these demands. There are essentially two categories of architectures we see in the multi-cloud ecosystem. A full stack application is the first category, where you got an entire stack, like the application stack and database stack and the web tier stack, all of that on one cloud, like the Oracle Cloud Infrastructure, talking to another entire stack placed on another cloud service provider. It could be Azure, it could be AWS, anybody. But the need here is usually for things like analytics and reporting, where batches of transactions are passed between one stack to the other. So in a full stack deployment, it's usually batching of data interactions. So throughput could be important depending on the traffic that's being passed through between each stack, but the latency itself may not matter as much. Now, in the second category of applications, we look at split stack applications, where a typical deployment is cross-platform and cross-cloud. For example, it could be an Oracle Analytics Cloud application, which we have as an example later down the line, talking to something like AWS Redshift database that's deployed on another cloud service provider, AWS in this case. So here you absolutely need low latency due to the high online transaction processing nature of these interactions. And you also need high throughput due to the constant and consistent traffic between the two stacks, between the application stack and the database stack. And typically that connection needs to be highly reliable, high throughput, and extremely low latency. Next slide.
Thank you, Matt. So obviously we see that low latency, high throughput is imperative, but having that type of connectivity can become a challenge as infrastructure continues to become more distributed. Really, that's the whole impetus of Megaport, right? Our vast ecosystem provides the reach and flexibility required to seamlessly connect wherever that infrastructure sits. So these are some of the most common ways that customers use our platform today. For those hybrid scenarios, we see these DC to cloud deployments, really bridging that gap between the physical and virtual infrastructure. We also see high uptake of cloud to cloud deployments to support split stack architectures or even full stack, as mentioned earlier. With the ability to support this, in addition to dynamic backbone between data centers, virtual edge solutions for secure access to branch locations, and internet exchanges across the globe, we can ensure you have access to your resources with full control. Even better, you can do all of that in 60 seconds with just a few clicks. So what does this all look like when brought together in practice? Matt's going to walk through a cross-cloud use case that we developed together.
So thanks, Chris. This is a live example that we developed in the solution centers. It talks about AWS Redshift data warehouse that's located on the left in AWS cloud. And this part of the stack is heavily database centric, with Redshift getting feeds from different disparate operational systems. On the right, you see a application stack running Oracle Analytics Cloud, powered by autonomous data warehouse in the OCI cloud infrastructure. So here, Megaport formed a VPC, or a virtual private cloud circuit, between these two clouds and between these two CSPs. Megaport's cloud router solution was used to connect between the Fast Connect on the OCI side. There was a Fast Connect partner edition on OCI that was used, which is enabled by Megaport. And then on the other side, direct connection to AWS was formed. So between these two clouds, Megaport had this VPC established using the Megaport Cloud Router solution. Most of our transactions were data-centric in nature. There was consistent and constant data pulls from the AWS Redshift into the autonomous data warehouse, which was then farmed off to Analytics Cloud for dashboards and reporting. So you see, this is a classic example of a split stack architecture where there's constant traffic between the database stack and the application stack. And for most part, we achieved less than 1 millisecond, but generally we're used to the notion of achieving a sub 2 millisecond latency response times, which is phenomenal given the high OLTP nature of this application. There are several practical use cases that come to mind that could leverage this kind of architecture. For example, financial services or even retail industries, where the customers need to modernize and reduce their risks. For example, global banks tend to modernize by localizing their regional strategy, for example. The regional banks have to adhere to certain standards globally, but they're given the autonomy to have their own systems regionally, right? So this is a classic example where a regional bank's systems talk to the corporate network or the corporate global HQ for compliance, for dashboards and reporting on a quarterly basis or on an annual basis. So things like looking at the impact of global HQ ratios and how some of those economic drivers can impact at a regional level. The impact could be cash flows, it could be liquidity, it could be any number of regional parameters that drive a regional bank's performance. So a lot of practical examples also come in. Retail is another good use case that has similar needs and similar demands. I'll let Chris walk through the details and benefits of this connectivity specifically. And later down the line, Kevin's going to show us a demo of how the Megaport Cloud Router enables this multi-cloud connectivity.
Thank you, Matt. So as mentioned, really leveraging private connectivity has intrinsic benefits on application performance because the latency is consistent and predictable. So focusing on Megaport and how we deliver network, in this exact scenario, we reduce egress by up to 77% with the data coming out of AWS from that Redshift database over Direct Connect versus the public internet. In addition, the provisioning time to actually establish this cross-cloud connectivity is not months, weeks, or even days. We can actually have this up, deployed, BGP established on both sides and routes propagating in 8 minutes, which we'll highlight in a few moments in the demo. Before we dive into the demo, I just want to highlight the products that are going to be deployed just for additional clarity. And there's really 3 primary elements. The first component, the access, right? The Megaport Cloud Router or MCR. And this is a managed routing platform with integrated control via the Megaport portal, which we'll see in a few moments. But as mentioned, it can also be controlled via Terraform and our API. And then off of that access service, that MCR, will be deploying virtual cross connects or VXCs. And these are direct Ethernet connections to any endpoint on our network. In this scenario, we're connecting to Oracle Cloud or OCI, leveraging Fast Connect, and to AWS, leveraging Direct Connect. So I'm going to hand it over to Kevin now for the demo.
Thanks, Chris and Matt. Thank you both. All right, just give me a thumbs up if you can see what I'm sharing here. You guys able to see my screen?
Yes.
Okay, great. All right, so just before I get into the demo again, this is what I'm going to show you what we're building. 3 key components: the Megaport Cloud Router, the AWS Direct Connect, and the Oracle Fast Connect. And just keep in mind, all the traffic that will be, moving between the 2 clouds is not touching the internet ever, right? So again, emphasizing from a security perspective, private networking, through the Megaport Cloud Router. Last key point here I want to just point out is I'm going to be specifically deploying this in the Washington, D.C. Metro at a data center operator location where Megaport has our cloud router, specifically core site. And also want to emphasize that our physical peering with both Oracle and AWS in the US East regions are also in that same data center. So from a latency perspective, this is about as optimized as you can get. So with that, let me just jump over to the Megaport portal. So as a customer, this is the main dashboard you would see when you log in. Again, I want to drill down here to the DC metro area, so I can just type that into our search window and select Washington, DC. And then I'm going to start to drill down into that metropolitan area, and I can start to see the data center location. So core site is where I want to deploy. I can just select the option to create the Megaport Cloud Router here. Then I'm just going to choose next. And I can set the throughput of this cloud router. And you can see we've got options from anywhere from 1 gig all the way up to 100 gigs of throughput. So for the demo purposes, I'm just going to choose a 1 gig. I'm going to give this cloud router a name. I'm also going to set my billing terms here. And lastly, I want to put in my BGP AS number. By default, Megaport will give you one. I'm going to use a private AS based on the config that I'm using here. So I'm going to just choose next, select add to MCR, and it's going to ask me to confirm a few steps here, and I can just kick off the order. And that's basically spinning up that virtual Megaport Cloud Router. So I can hop over to what we call our services section, which if I show you here, you can see that the cloud router is in the process of being deployed. But while I'm actually waiting for that to spin up, I can start building my connections to both Oracle and AWS. So I'm just going to click Add Connection. And that's going to bring me to the destination type. And in this case, it's going to be a cloud. I can choose Oracle Cloud. And key piece of information here is what I need is the virtual circuit ID. So I can hop over to my OCI console and I can go into the Fast Connect section. I've already pre-provisioned it on the Oracle side. You can see that it's in a pending state through a partner. In this case, the partner is Megaport. But I can go ahead and grab that OCID. I can copy it, flip back to the Megaport portal, drop that in, and it's going to populate the list of on-ramps. Now, again, from a latency perspective, I want to choose the local on-ramp. In this case, it's core site. My cloud router is deployed in what's called the red zone. So I can actually, from a diversity perspective, I want to align my connection with that red zone. So just want to highlight, the fact if you want to build high availability into your architecture, we've got that capability with our red and blue zone. So I'm going to select the Oracle on-ramp here, specifically this red local zone. Once I select that, I can go ahead and choose next. Here, I'm going to give this connection a name. This is just a reference name. This is a key part here, is the rate limit. Now, this is how you set the bandwidth on any Megaport connection, really. And this is all adjustable. So I can go, in this case, I can go up to 1 gig. If I wanted to, I could just leave it at 100 meg. But just trying to point out that this is where the option to change the bandwidth is available. So here, I'm just going to go ahead and type in some specific parameters about the peering segment. So this is the IP address that's going to be assigned to my Megaport Cloud Router. Made a typo here. It's got to be a .1. Then I'm going to specify my BGP peering segment. I'm going to plug in the IP address on the Oracle Fast Connect side. And I also need my AS number for my peer, which in this case is Oracle. And I can grab that information right from the BGP section of the Fast Connect. In Oracle, it's always going to be the 31898 AS number. So I can just drop that into the console here on the Megaport side. I can go ahead and click add, choose next, and there's a couple confirmation steps. But while I'm in this segment here, or this section of the portal, I'm going to go and add the last connection, which in this case is going to be AWS. So it's going to be sort of the same workflow. Choose cloud. Only difference is I'm choosing AWS. There's a couple different options for the connection types. I'm going to choose a hosted VIF. And again, you can see the on-ramp here is where I'm going to choose the local on-ramp to core site. Again, I'm going to give it a name. This is where I'm also going to set the bandwidth and the billing terms as far as how I want to pay for this connection. Once I choose next, there is a key difference here on the AWS side specific to the cloud router. The API integration is basically going to automatically configure some of these parameters, which I'll show you on the next step. But I do need to plug in my Amazon account ID. So if I jump into the AWS console, I can grab that, copy it, paste it, and drop it in here. I also need an AS peering for the Amazon side. So that AS number, I'm going to populate in here. This is my Amazon side, and the BGP and subnet information. This is what I was talking about. That's automatically going to be configured on the deployment to my cloud router. So I've got the two connections in the queue ready to be deployed. At this point, everything looks good. I can go ahead and click to the next step to basically validate that order. And then I can go ahead and select order now, and that's going to kick off the deployment. So what's happening now behind the scenes is we're building these layer 2 segments to both AWS and Oracle from the cloud router. Okay. So the status right now in the Oracle Fast Connect side of things, you can see that it's actually provisioned, but this is only the layer 2 segment. It'll take a few minutes for BGP to become fully established. But while I'm waiting for that, I'm going to jump over to the Amazon side because I do need to accept the connection there. So again, the workflow is a little different between all the different cloud providers. So in this case, in AWS, I'm going to accept that connection. And here's where I can attach it to in this case, it's a direct connect gateway. This is where I'm going to actually peer to AWS. So I can select this direct connect gateway, click accept, and now you see it's in a pending state. So again, layer 2 is going to be established. Eventually BGP status will be up. But if I flip over to my cloud router, we can select what we call the looking glass, and this is where we can start getting into the specific BGP parameters, some of the configs, and the route table. And you can see here that I've already established BGP with the Oracle environment through the Fast Connect segment. On the direct connect side to AWS, it's still showing that it's waiting to establish. I can probably just do a quick refresh and I should start seeing my route table populate. There we go. So now my cloud router, you can see I've got the routes that I'm learning via the Fast Connect to Oracle, also the routes that I'm learning via the direct connect to AWS. And I can even jump into both consoles. On the Oracle side, I can go in and check, in this case, it's called the DRG. I can check that route table. And you can see these two subnets here that I'm highlighting, those are actually from the Amazon side. And if I jump over to the Amazon console, do a quick refresh, you can see that these subnets here are from the Oracle Cloud environment. So at this point, I've got layer 2, layer 3 connectivity. I'm learning routes. Essentially, I've just deployed, again, that Megaport cloud router with the Fast Connect segment to Oracle. and the AWS connection via Direct Connect. So if I jump back to the diagram here, this is essentially what I've just built. And lastly, I just want to point out that what I showed you was through the web interface, the click-through process. Everything in Megaport has is available via API calls. So we have a Terraform provider, for example. So what I just showed you can be completely automated through something like Terraform. So that becomes pretty powerful when you start thinking about, building out at scale, and even from a high availability perspective, being able to spin something like this up in a matter of minutes. So that concludes the demo portion. So I will stop sharing and hand that back over to you guys. Thanks.
Oh, perfect. Thank you so much, Kevin. Just to make sure that everyone's aware, we will be sending out the materials we covered today to everyone who registered. As you can see here, there are great resources available on the use case we discussed today and additional ways to maximize Oracle services. Also want to point out that if you are interested in a consultation and an in-depth demo, architecture review, feel free to use the QR code here and fill out the associated form. Just want to say thank you again for joining. Happy Friday. And at this point, I'd like to open up the floor for any questions. And again, you can use the chat, or you should be able to unmute yourself at this point if you want to ask anything. Perfect. Don't be shy, but going once, going twice. Well, thank you again. As always, feel free to reach out if any questions come up later today or after you review the materials once again. When you have them, feel free to reach out directly via the form or to any of us that are on this panel today. More than happy to answer any questions or help with any work that you're trying to produce. So thank you again and take care.
Thank you.
Thanks, everybody.